Okay. And today, like I said, is a continuation of section 6.3 and the notes from Friday. Okay. So back on Friday, day one of these notes, we discussed the square root function, took a look at all the different shifts, and kind of just talked about that as we were going over the homework. So let's remember the different kinds of transformations we had. Anything that's underneath our square root, it affected our graph horizontally. So I either moved to the left when I was adding or moved to the right when I was subtracting, okay? Anything on the outside of my square root affects my graph vertically. So I moved up when I was adding and down when I was subtracting. Hopefully we remember this and we made a key for that back on Friday, all right? In today's notes, instead of adding and subtracting, we're gonna look at what happens when we multiply on the inside or the outside of our square root and how that affects our graph, okay? So we're gonna take a look at this first example here. We're gonna go through what happens when we multiply by different numbers on the inside, then on the outside, and then we're gonna actually see a mix of transformations, whether we're adding, subtracting, multiplying, and kind of combining all those ideas. Does anybody have any questions before we start? Okay, so my first function here, y equals the square root of 2x, all right? You see this note here, I said very similar to before, choose values that you know will give you a perfect square. If you need to, for each problem, write out what some of those perfect square values are. You know the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. 9 and 3. 16 and 4, so on and so forth, right? You want to see, if possible, how you can get to those values underneath your square root. And the same goes for when we're multiplying, right? We did it with addition and subtraction. Same thing goes with multiplying. So this first example, I gave you kind of the table of values to choose. If you plug in 0, well, that gives me y equals the square root of 2 times 0, which is the square root of 0, which we know to be what? Just 0. The second value, y is equal to 2 times 2. Well, that's going to give me the square root of 4, and the square root of 4 gives me what? 2. Next one, square root of 2 times 8. Well, that's the square root of 16. And what's the square root of 16? 4. Right? So there's, again, some strategy behind the values that I choose to make sure I have a perfect square. Any questions about how I found those values? Yeah. A little bit better. Now I'm going to go through and plot these points. So I'm at 0, 0, 2, 2, and 8, 4. I'm going to draw my graph. Well, it might not seem like there's much of a difference between our original square root function and the one that we just drew. However, think about just the square root of x, right? And some of the perfect squares that we've discussed. What's the square root of 4? 2. So when I plug in 4, my y value should be up at 2. Notice that when I plug in 2, my y value is up at 2. What's the square root of 16? 4. But when I plugged in 8, I got 4. So all of my points are being shifted down, or what we say is compressed or shrinked in that horizontal direction. They're now 1/2 of where they actually should be. So instead of being at 16.4, you're at 8.4. Instead of being at 4.2, you're at 2.2. All right. So it's taking that and horizontally shrinking your values. Okay. And that happens when we multiply underneath our square root by a number that's greater than 1. All right, so that's our first rule or our first key that we need to kind of understand. Are there any questions about that first example? Okay. You see that here, it's we just talked about it, but visually now you have a little note there. So when the constant we're multiplying inside our square root is greater than 1, we have a horizontal shrink by actually the reciprocal of that, right? Notice that we had 2 and they were all 1/2 of each other, all right? So what do you think is going to happen now if I have a number that's a fraction? Instead of shrinking, it's going to do what? Expand, right? Or stretch. You hear a lot of those words kind of being used interchangeably. All right. So let's see if our assumption is correct. All right. Again, I kind of give you the table of values here to plug in. And that's because we want to be strategic. What's 1/2 times 0 going to give me? And what's the square root of 0? 0. What's 1/2 times 8 going to give me? What's the square root of 4? 2. Choosing values that'll give me integer y values here. What's 1/2 of 32? 16. What's the square root of 16? 4. Any questions about how I found those values? So the first example we saw, we multiplied by a number greater than 1, we had a horizontal shrink. Our assumption was that if we multiply by a fraction, a number between 0 and 1, our graph would expand or stretch, right? Well, I have the point 0, 0, the point 8, 2, and the point 32, 4. Well, I don't have that on my x value here, so I'm just going to draw those two and start my graph. Was our assumption correct? Did my graph stretch out from where it should be? Yeah, right? If it was just the square root of x, when I plugged in 4, that would give me the point 42. Notice that here I'm at 8, 2. So it's stretched, it's now double the x value of where it should be with the same y value. Does everybody comprehend that idea? So it's taking those x values, moving them out, but keeping the same y values. So when I do that, I'm stretching. And that's always going to happen when my point that or not my point, excuse me, the number that I'm multiplying by underneath my square root is between 0 and 1. All right. Again, notice the common theme. When something's underneath my square root, whether I'm adding or subtracting or now multiplying, it's affecting the graph horizontally. All right. So we have that at the bottom there. This should actually say when c is greater than 1. So that's my bad with the typo there. But kind of just outlines everything we talked about. If c is a constant, we multiply underneath our square root. So inside, bless you, inside our square root, bless you. We saw that it shrunk. When c, that number was between 0 and 1, so this fraction, like we saw 1/2, we have a horizontal stretch. Our graph gets stretched out horizontally. All right. Any questions about those first two examples or when we multiply underneath our square root? Okay, because now we're going to transition into seeing what happens when we multiply on the outside of our square root. All right. How do you think this would affect the graph? Is it going to affect it horizontally anymore, or how's it going to affect it? Vertically, right? Just like when we added or subtracted on the outside, it moved it up and down. Now when we multiply on the outside, it's going to either stretch or shrink, but in the vertical direction. All right, so just kind of keep that in mind. All right. Another note that I have written here, because there's no multiplication or addition or subtraction inside my square root, we can just choose traditional values that are going to give us a perfect square. Notice that my table is blank here, and when you go to your homework or on the quiz on Friday, you're going to have to make your own table. What should I plug in for x for this particular example? Okay, 0. What else? So if I plug in 2, I have to do the square root of 2. Right, so 4. Because I'm trying to make sure I don't have any decimals, or 9's fine as well. Could have chose 1, could choose 16, whatever's easiest for you to kind of understand what's going on here. But choose values are going to give you a perfect square. One thing that we need to make sure we understand also, when my 3, I'm being multiplied on the outside, this is really 3 times in parentheses the square root of x, right? I have to take care of what's in the square root first before I multiply that value by 3. Okay. So with that being said, what's the square root of 0 going to give me? And then what's 3 times 0? 0. So my first point, 0, 0. What's the square root of 4 going to give me? 2. And then what's 3 times 2? 6. Square root of 9. And then 3 times 3, 9. So my points are 0, 0, 4, 6, and 9, 9. Are there any questions about how I found those points? The work is there off to the side, just in case you need it. Any questions about how we found those? So let's go through and now draw this graph. I have the point 0, 0. 4, I'm all the way up at 6. 9, I'm at 9. So my graph looks definitely different than my original square root function, right? We said that when we're multiplying on the outside, just like when we're adding, subtracting, it's going to affect it vertically. Well, how would you describe this? Is this a vertical stretch or a vertical compression or a vertical shrink? Stretch, right? Usually I'm at the point 4, 2. Now I'm all the way up at 4, 6. Usually I'm at 9, 3. Now I'm at 9, 9. So my graph is being vertically stretched, and it should make sense. Notice those y values are all 3 times where they should be, because I'm multiplying by 3 on the outside, right? Instead of being at 4, 2, 4, 6, 9, 3, I'm at 9, 9. So it's being stretched, and that's always going to be the case when I'm multiplying my numbers greater than 1 on the outside, all right? So again, just to, emphasize that point, anything that's on the inside of my square root is horizontal. Anything on the outside is vertical, all right? Any questions about that? Or anything related to that first example there? So my number is greater than 1, vertical stretch. What do you think is going to happen when it's between 0 and 1? It's going to shrink vertically, right? Because it's on the outside. Let's see if our assumption is correct again. In this example, I have 1/2 square root of x. Again, when we need to make sure that we know that's 1/2, we're taking care of the square root again by itself. And because I'm doing the square root by itself and there's nothing really interfering with that on the inside, what x values should I choose to plug in? 0, 4, 9, 0, 1, and 4, whatever has a perfect square, right? There's nothing that's being added or subtracted to that. I want to choose values that'll give me even integers on the outside, all right? Nicer numbers to work with. So 0, 4, and 9 works. So now I'll have 1/2 times the square root of 0. What's the square root of 0? And what's 1/2 times 0? 0, right? Anything times 0 just gives me 0. Pretty consistent that when I'm just multiplying, I'll still have that 0.00, whether it's on the inside or the outside. It's just something to kind of keep in mind. Although when there's multiple transformations, that's not always the case. Okay. What's the square root of 4? And what's 1/2 times 2? 1. What is the square root of 9? 3. And what's 1/2 of 3? 1.5. You could say 3/2 or 1.5, either way. Might be easier to work with decimals in this case since we're plotting points, right? You can kind of, it's a little bit easier to know what like 1.8 is rather than 9/5, right? So work with decimals if you need. Any questions about how I found these points here? Right, just a matter of plugging them in. Let's go through and plot them. I have the point 0, 0. 4, I'm at 1. 9, I'm at 1.5. What happened to my graph from its original form? Shrunk vertically, right? If I plug in 4 into the square root function, I should get 2. Well, now I'm at 1. If I plug in 9, I should be at 3. Now I'm at 1.5. It's 1/2 of all of the y values from the original function. So it shrunk vertically, right? Or compressed vertically. You'll hear each of those words kind of being used interchangeably. And that's always going to be the case when the number on the outside is between 0 and 1. Okay. Are there any questions about that example? Okay. You see here, again, there's a little note at the bottom. So if C is greater than 1, that should say 1. There's another typo there. What we saw, C is greater than 1, it stretches, right? Multiplying all those y values by whatever that number is on the outside. Between 0 and 1, it shrinks, right? It'll be 1/2 or 1/3 of the original value, all right? We need to make sure that we keep all of these ideas, in order when we're adding or subtracting on the inside or outside and multiplying on the inside or outside and how that affects our graph. Because now what we're going to take a look at for the next 2 examples are if we have multiple transformations. All right. So maybe we're moving to the left and shrinking, or we're moving, up and compressing, whatever it may be, we're going to combine all these ideas. All right. Are there any questions before we do that? Okay. So like I said, there's a lot to kind of keep in mind. What I would suggest doing is going through, when you have problems like this, you'll see 2 examples on your homework tonight where you'll have multiple transformations. And I would write out what the transformations are prior to starting, because that way, as you go through and you're starting a graph and it might not look like it's, doing what it's supposed to, you might need to change your values that you plugged in or kind of see where you went wrong with your work. So let's do that now in these couple examples. All right. Let's start by just writing out these transformations with maybe the 1/2. So I know I have a 1/2 being multiplied on the outside. So what kind of transformation is that? What's going on with my graph? And remember, if something's on the outside, it's affecting it vertically, so you can kind of narrow it down there. Inside's horizontal. Going to shrink vertically. Good. How do you? on a second. Multiple people. Yeah, your mic's on, bud.
Oh, sorry.
All good. Whatever. It's all good. Okay. All right. So yes, vertically shrink, and it's by 1/2. All right. What happens when I'm adding inside my square root? So this is something that we actually talked about back on Friday. Because remember, addition and subtraction, you're not worrying about shrinking or compressing or stretching, right? When you're adding or subtracting, you're shifting. So you're either moving to the right, left, up, or down. So if I'm adding 3 underneath my square root, where am I moving? To the left, right? So before we even start, we pretty much have a decent idea of what this should look like. It should be shrunk half the size of the original one, so in the y values, and then move to the left 3. Any questions about how we found that out or understanding some of our transformations? Okay. Now we still need to be pretty strategic about the x values that we choose to plug in, right? I still want to make sure I get maybe the square root of 0, square root of 1, square root of 4, 9, 16, so on and so forth. So if I take a look at maybe that first perfect square, the 0, what number should I plug in for x so I have 0 underneath my square root? -3. Does everybody understand how we got that? So I'm trying to get 0 underneath. I'll plug in -3. My next perfect square would be 1. Well, what number should I plug in for x so I have 1 underneath my square root? -2. Good. How do I get the square root of 4? If I plug in 1, right? Take it step by step, right? Don't try to do too many things at once. Just choose those x values, then go back and start to evaluate. All right. So, show some of the work off to the side here. Of 1/2 square root of -3 plus 3 is going to give me a square root of 0. What's the square root of 0? And what's 1/2 times 0? 0. Right, so 1/2, -3 plus 3 gave me the 0. Square root of 0, 0. 1/2 times 0 is 0. -2 plus 3 is going to give me 1/2 square root of 1. Well, what's the square root of 1? Well, it's 1, and then 1 times a half is going to give me the 1/2 or the 0.5. That's good. All right. So -2 and then 0.5 is your y value, yes. When I plug in 1, I get 1/2 times the square root of 4. Well, what's the square root of 4? And then what's 1/2 times 2? 1. So my points are -3, 0, -2, 0.5, or -2, 1/2, and then 1, 1. Are there any questions about how I found those y values or why I chose the x values to plug in? Okay. Let's plot these points then. So -3, 0. It's already starting to look good with our transformation moving to the left 3, right? So we're pretty much on the right track. -2, I'm at 1/2. And then at 1, I'm at +1. So my graph looks something like this. And we have a pretty good idea that yes, we moved to the left, but we also vertically shrunk by 1/2. Okay. Any questions about that first example dealing with multiple transformations? Like I said, you will see a couple examples tonight on your homework where you kind of have to do a few things. Any questions? Okay. Let's take a look at this second example then we'll talk about the homework and call it a day from there. All right. Very similar to before, right? And if you need to, under each question, write out some of those perfect squares so you know kind of what you're aiming for here. This should also say, sorry, another typo. Should say square root of 2x minus 4. So instead of 3x, it is 2x minus 4. After you write out some of those perfect squares, again, just like we did above, let's write out what some of these transformations are going to be. All right, take it step by step. Just look at one at a time. If I have 2 times x underneath my square root, right? Remember, anything that's underneath, you have horizontal transformations, so you can already eliminate the vertical stuff. What's this going to do when I multiply it by 2 underneath my square root? Not expand. It's going to shrink it. So this is going to horizontally shrink my graph, right? Remember, it's kind of the opposite of the vertical idea. So if it's greater than 1, it's shrinking underneath. If it's greater than 1 on the outside, it's stretching it. So there are some things that you kind of need to take into account. It's also probably going to shrink it by half of what we are usually doing since it's 2 times. What about the minus 4 on the outside? So now again, if it's something is on the outside, it's going to move down 4, right? So it's affecting it vertically since it's on the outside. So it's moving it down 4. Any questions about how we came to those conclusions? Okay. So I have square root 2x minus 4. Well, what should I plug in for x? So maybe I get the square root of 0 there. 0, right? 2 times 0 or anything times 0 will give 0. It's a pretty safe bet to choose that to plug in. All right. You can think about getting to the square root of 1, but then you have to plug in 1/2, and then you have to plot the point 1/2, whatever that integer is going to be. So you might want to just go right to the square root of 4. What number should I plug in for x so I have the square root of 4? 2, right? If you plugged in 1/2, it wouldn't be an issue. It's just that sometimes it's easier because now I have to go like 1/2 up at 1. You're kind of in between integers on your graph. It's just a little bit neater choosing those numbers to work with. What should be the next number I plug in for x and y? 8. Why is that? So it gets me the square root of 16, right? You don't want to deal with the number that's going to multiply by 2 to get you to 9 just to be able to have a square root of 3, right? Because then you're still dealing with decimals regardless. So let's plug those numbers in and see what we get. 0 times 2 gives me 0. What's the square root of 0? And what's 0 minus 4? -4. Good. Two times 2 gives me the square root of 4. What's the square root of 4? And what's 2 minus 4? -2. Two times 8 gives me 16. What's the square root of 16? And what's 4 minus 4? 0. Okay. Any questions about how we found those values? Just plugging in those X's and then kind of simplifying. Remember, you take care of what's underneath your square root, or take care of your square root first, and then work with anything that's on the outside. So I'm at the point 0, -4, 2, -2, 8, 0. I'm going to plot all of those points and draw my line. What we said before we started was that we would move down 4, which we did. The horizontal shrink, we saw this in the very first example we did today. It's a little hard to see, but if this was just the square root of X with the -4 on the outside, well, if I plug in 16, that would give me 4. 4 minus 4 gives me 0. Well, right now I'm at the point 8, 0. So I'm 1/2 of where I actually should be. So that kind of clarifies that I did shrink in the horizontal direction. All right. If you're having a hard time seeing that, just choose values where if it was just the square root without any multiplication, it might help you kind of justify what's going on there and that you have the correct transformation. Are there any questions about either of those last two examples of multiple transformations or anything that we covered today? Okay, let's take a look at the homework for tonight. So if you go to the marking period 3 folder and you go into today's date, your homework for tonight is page 403. You're doing numbers 19 through 25, the odds. All right, so just 4 problems. See, 19, you're multiplying underneath your square root. 21, you're just subtracting underneath your square root. So those are kind of similar to what we saw earlier today and on Friday. 23 and 25, you have multiple transformations. So write down what those are prior to starting and then see how that affects your graph. Choose appropriate values that are going to give you a perfect square underneath your square root. When we come in tomorrow, we'll go over that homework assignment and then continue with review for the quiz on Friday. We're going to start with section 6.1, which we did prior to the spring break. All right. We'll go through some of those examples, and then each day will kind of just be a new section for us to review in preparation for the quiz Friday. All right. Any questions for me?
I got a question.
Yeah, what's up?
For the homework, do you want us to graph it, or can we just put it, just like find the X and the Y and just find if it's horizontal or vertical?
So no, I want you to graph it as well. So definitely go through all those steps, right? Find the X and Y values, understand what the transformation is. So kind of like write that down ahead of time, and then also draw a sketch of the graph. Yeah. So make a coordinate plane on your homework and then just draw out what that would look like. Okay. Good question though. Any other questions? Okay.